This video is going to show you how to conduct a Kruskal Wallis test in JASP. Think of a Kruskal Wallis test as simply a non-parametric equivalent to a univariate ANOVA. So it's used when we have a between subjects independent variable with more than two levels to it. If you only had two levels, you could do a Mann-Whitney U instead. The example that we're going to be looking at today, we're going to look at three groups of different statistical program users. So we've got JASP, Spss and Excel users, and we ask them how contented they are with their program of choice on a 1 to 7 Likert scale. We can make the case, because it's a Likert scale, that it's ordinal data anyway, and we should be treating it as non-parametric data. We can explore this data a little bit more if we go to descriptive statistics, and we can produce some plots so we can actually look at the distribution of this data as well. So our dependent variable contented, and then we can look at our plots for it, and we can look at our distribution plots, and this is just a histogram. And as you can see, we don't really have normal distribution. We can also ask for a box plot as well to show us pretty much the same thing. So we've got actually no whisker at the top end of this at all. A really nice feature that we have on JASP is it allows you to do the violin plot over the top. Violin plot's good in as much as it's a really nice way to visualize data, shows distribution really nicely, and it plots all the points on the data as well. The other thing you may sort of notice when you look at this, if you cut this lengthwise and to rotate it 90 degrees, this sort of pattern here maps on really neatly to the histogram as well. You can see the little dip here represents that little dip there. So a violin plot's a really neat way you can look at distribution of data, and as you can see in the example we've got here, we clearly don't have normally distributed data. So that being said, we may want to report some different descriptive statistics than the ones we get here. For example, when we split it by program, so we can see we've got a mean, standard deviation, minimum, maximum for our three different statistical programs. If you go to statistics, you may wish to ask for some different measures. For example, you may want to have a range instead of a standard deviation. Instead of a mean, you may want to give the median response. And as you can see now, we've got our median scores and the range for the scores, and of course minimum and maximum stay like that because we kept them selected, or we can just redact things right down like that. Now, because we have program as the split here, you'll notice that the other thing that's going to happen is we get a histogram separately for each of the experimental groups that we have. Likewise, you'll see we also get 3 different violin plots and 3 different box plots as well. So when we come to actually running our analysis, we go to ANOVA. The way JASP works is it's based around, you make your decisions based on your different experimental designs under basically the title of ANOVA, but underneath the ANOVAs it allows you to do a Kruskal Wallis test, or you could do a Welch test or the Brown-Forsyth test, but it's based upon you've got a between subjects design. So we'd select ANOVA and program, it's our fixed factor, it's our independent variable, and contented is our dependent variable. It automatically produces this output as you select it as go along, but we're not going to be looking at this because we don't believe this is suitable for our data. Instead, we go down here and select non-parametric tests, and we just click across program, and this produces a Kruskal Wallis test for us. So the statistic here, the test statistic is actually a chi-squared test, although when writing up in APA format it's reported as an H. And we've got our degrees of freedom, our p-value, and as you can see we've got a statistically significant effect of the different statistical program people use on how contented they are. And we could just write this up accordingly. There's a significant effect of program on contentment. Now, as always, we should be producing effect sizes along with this. We can't produce an effect size for the Kruskal Wallis test directly here, but an effect size calculation can be done based on a chi-squared statistic, and it's a very straightforward formula. It is simply the chi-squared statistic divided by n minus 1, so your total number of participants minus 1, and this will give us an eta squared this is a rough proportion of variance in the DV that the IV accounts for. So we can do this calculation here, and as you can see, this gives us an eta squared of 0.57, and we report this accordingly. So we just follow up where we've written that we've got a significant effective program on contentment. We simply just add our eta squared to the end. One thing it's probably worth mentioning is that you can go to additional options and ask for estimate of effect size, and it will produce, as you'll see, it produces an eta squared. You'll see this one's marginally different. That's because this is an eta squared that's based on calculations around the sum of squares, not the chi-squared test statistics, so they differ slightly. So you'd be better off doing the calculation by hand. So what else can we do? Well, this is all very well. It tells us that program has an effect on contentment, and our descriptive statistics we saw earlier certainly indicate that JASP users tend to be more content than SPSS users and Excel users. But we can actually get post-hoc tests for this, and this is another good advantage it has over SPSS. SPSS there's a way of getting a Kruskal Wallis test to produce your post-hoc test, but it's actually a very unwieldy method for doing so. So the beauty of doing it in JASP is we can just go to post-hoc tests, we click across program. So this gives us some post-hoc tests here, but we don't want the standard ones, we want done. So these are our non-parametric post-hoc tests. So you'll see it gives us different p-values. It gives us your standard p, it gives you your Bonferroni, and it gives you your Holm p-value here. Whether you're going to use a correction or not is an a priori decision that you should be making before you do your analysis. In this example here, we'll just look at the standard p-value here that our done post-hoc test has produced, and it's compared our 3 different conditions. So what can we tell from this? We've got JASP versus SPSS, and you can see that there's a significant difference between JASP and SPSS. There's also a significant difference between JASP and Excel, and there's also a significant difference between SPSS and Excel. We know that based on the medians we looked at earlier, that JASP users are the most content, followed by SPSS and then Excel. If you want to interpret this table, we can simply compare these columns. So these just refer to the comparisons. So this is the comparison of JASP versus SPSS. So we get higher scores for JASP than we do SPSS. This comparison here is JASP versus Excel. Higher scores for JASP compared to Excel. And finally SPSS compared to Excel. Again, you can see the scores are higher here for SPSS than they are for Excel. So we could just write that up accordingly and just tell our reader that post-hoc done tests reveal that JASP group is significantly more content than the SPSS group. We can give our exact p-value here, as well as the Excel group, and then we report our p-value of less than 0.001. And then we can also state that content scores for SPSS are also significantly higher than for the Excel group, and we can report our p-value of less than 0.001 here as well. You could also give descriptive statistics when you're writing up those stats, or you could have a table of descriptive statistics separately, so the reader can see what, for example, you may want to be reporting medians here, so you can see the magnitude of these differences as well. You may also wish to have a look at a plot of this, in which you could put program on our horizontal axis. You can see a plot of the means here, in which you can see clearly higher scores in JASP compared to SPSS and Excel. And we could ask it to display 95% confidence intervals, and then we can see a nice, neat, clear effect, clear difference between our conditions there as well.